In this problem, you're asked to prove that tangent squared s over secant squared s is equal to 1 plus cosine s times 1 minus cosine s. Okay, so once again, it's best to start with the more complicated side of the equation. It might not be obvious here, but I tend to go for functions like tangent and secant that we really think of as like the reciprocal of cosine and sine over cosine. I would go for the one that's not in terms of sine and cosine, because there are some obvious steps to take usually with those sides. So I would start with the left-hand side. So we see tangent squared s over secant squared s. And I would rewrite that in terms of sine and cosine. So it's an important identity to remember that tangent, let me write tangent of x. I know the s doesn't look as clear maybe. Tangent is equal to sine over cosine. And secant is the reciprocal, it's 1 over cosine. Okay, so using those identities, you can write tangent as sine over cosine. So tangent is sine over cosine, and since it's squared, we should square the whole thing. Secant is 1 over cosine. Okay, but when you square a fraction, you just square the top and square the bottom. And same thing in the denominator here, 1 squared is 1 over cosine squared. Now, you've got a complex fraction. So to simplify that, notice that these denominators are the same, cosine squared and cosine squared. So if we want those denominators to cancel, we can just multiply by cosine squared in the numerator and denominator of the outer fraction here. So if you multiply by cosine squared on the top and bottom, then it cancels both of those denominators, and you're left with sine of s squared over 1. So you're left with just sine squared s. Now at this point, you'd take a look at, okay, so where's the finish line with this one? And it's here. It's this 1 plus cosine s, 1 minus cosine s. And so if you're still feeling like you're just feeling your way in the dark with this, you could think, okay, well, at least I need to write this in terms of cosine instead of sine. And so you have to remember the identity. Okay, so cosine squared plus sine squared is equal to 1. So this sine squared that we have by itself is equal to 1 minus cosine squared if you move the cosine squared over. And that's what we want to use here. So the sine squared is equal to 1 minus cosine squared. So now we're a step closer. It's at least written in terms of cosine. And then you glance up at that right-hand side again and notice that that's in factored form. And that this that we have down here is a difference of squares. I mean, that 1 you could think of as 1 squared minus the cosine squared. Don't have a lot of room there. But so it is a difference of squares, and so maybe you recall how you factored a difference of squares. It's 1 plus, oops, not squared. I'll erase that. 1 plus the squared term in the second part, and then 1 minus. And the order there doesn't matter, you know. When you multiply, order doesn't matter. Multiplication is commutative. Okay, but so now we're landed at the right-hand side, and we have verified the identity.